Alright, we're talking about contactors here. Uh, right now we have a single pole contactor here. This could be used for 120 volt applications or 240, but one of the legs is going to be connected. So say this is 120 volt, this will be your common wire right here, and you could break your hot wire coming across here. So you control if this plunger goes down with 24 volts getting applied to this coil here on the side. All right, when you apply 24 volts to the coil, it sucks the plunger down, closing the electrical circuit and allowing voltage to flow through. When you do not apply voltage here, then the connection here on the hot wire stays open and it's disconnected. All right. The problem with these is a lot of times that you see maybe some dirt gets in the contact or a cobweb from a spider or something gets in there and stops the contact. Even when you have 24 volts going to the side, it doesn't suck down all the way. It doesn't make a good contact. As well, if this was used for an amperage rating higher than what it's stated as, right here it says 30 full load amps. All right, if you were running that heavy all the time at a highest amperage rating, these contacts would eventually burn out inside right here, right in here. Okay, so what we're going to do is we're going to first test this coil out and see if it has resistance. How we would do that, we'd turn our multimeter on to resistance, and then we're going to clip one side to one part of the 24 volt coil, and we're going to clip the other side of our multimeter onto the other side of the 24 volt coil. All right, our multimeter says 15.5 ohms of resistance, so that is good. All right, if it did say OL, just like it says right now, over limit, then that would mean that this coil is actually burnt apart right here. Okay, if it said 0.00 ohms, then what it would mean then this coil is all burnt together. All right, and there's no resistance to electrical flow. And if that's the case, then no work will be done. Okay, and it will not suck down. All right, so we did that. Now we can actually go ahead and connect this to a transformer. I have this 120 volt to 24 volt transformer right here, and we can plug one side into one lead and one into the other. And then when I go ahead and turn it on, it should suck the contact down. All right. So I'm going to put it here so you can see it a little bit better. All right. Okay. You can actually hear maybe a little bit of humming noise. I don't know if that's coming through or not, but you'll hear a little bit of humming noise. If a customer calls and says, hey, my outdoor unit is not turning on, I ask them, do you hear a little bit of humming noise? If you do, then that normally means the contactor is sucked down, which means you're getting a signal from the 24 volt wires from the indoor unit. That may mean that maybe there's a capacitor bad on the outdoor unit and it's not able to help turn the outdoor fan or the outdoor compressor on. But right now we have it sucked down, and if we take a continuity reading, we can see if this contact is closed now. Alright, it's making noise. The multimeter is making noise on continuity, which means that the connection is closed. So we're going to go ahead and unplug this. Alright. Yeah. This coil right here is susceptible to water damage, alright, or humidity and things like that, heat. Alright. So the manufacturers have come up with a couple solutions. One, they covered the coil right here. Alright, a lot of the new ones they have a covered coil, and then also they're protecting their contacts from excessive heat and also spiders. Funny enough, spiders are a big problem climbing in there and making webs and stuff like that, especially in the off season, right? Alright, so that's that. This one's a 2-pole contactor. Alright, so when you apply 24 volts to the side, both poles close. So this would be for a 240 volt circuit. You could use it for a 120 volt circuit still, that's up to you. But then you could just use one leg and then just keep your common connected at all times. All right, this one, the Fla rating is 40 full load amps on this. All right, so you want to size these to make sure that you're not running excessive amperage through there. If you're afraid that that's going to happen, then you're going to need to size the contactor, get a bigger full load amp contactor. All right, this is a 2-pole. This is a 3-pole contactor, and obviously very large as well. All right, this one here has a cover as well, and it protects the contacts. All right, you can press these down by your hand. If you do that, we can We can get a continuity reading on here as well. You can hear it. Okay. All right. So when you press this down, you will get voltage going across here. All right. Some people push these down during a pump down of an outdoor unit to pump the refrigerant into the outdoor unit. I prefer using something like this. So on a condenser, all right, on a condenser that does not have a reversing valve, you can actually put the 24-volt connections onto the contactor, and this will suck down. And then when you're ready, you can then disconnect it. It's safer, so you don't have to press your finger near where that amperage is running through at. Okay, but anyway, that's that.